Willkommen, bienvenue, and welcome back to the Modding of Isaac with Lyte. Today's episode is on pickups, both custom ones that you make yourself, and at least slightly hooking into the ones that already exist. We're not necessarily replacing the behavior, but we're trying to hook into what we can. Now, the pickups we're going to make today are not really doing things that you want. They're not adding any real functionality. I'm just showing you the groundwork for how to make them. Then you can go and make them do what you like. So let's get in here, get it started, take a look at what these new pickups look like. Let's go in as Cain. Yeah, sure, Cain is fine. We don't want darkness. There we go. First thing you'll notice is up on the upper left, we've got some sticks and we've got some stones. 49 sticks and 2 stones to be exact. That's interesting. We've got ourselves a little overlay type thing going on over there with some shiny new graphics with some numbers. Then if we go into the console, spawn in a pickup 4787.1 and then .2. We've got ourselves a stick and a stone. Gorgeous. If we pick up the stone, it makes a little sound, and we've got 3 of them. And then we pick up the stick, and 50. And so, yeah, we've got pickups. We can pick them up by running into them. Also, I added a little bit where if we spawn 5.10, yeah, .1, then 5.20.1. So we've got a heart that still gets pushed around and nothing happens. If we pick up this penny, it turns into a spider. Ooh. Then let's spawn ourselves. Is it 85? Yeah. A red spider. We might need another one. Oh no, we've taken some damage. So now we can pick up this heart, and when we do, we get a fly. So it's not just proximity, but it's actually picking up the heart that leads to the fly. Similarly, give item quarter is C74, twice, thrice, let's just do it 4 times, such that we're up to 99 cents. Now if we spawn another penny, we still get another spider. We didn't gain any wealth, but we did get the spider. So those are the primary things I wanted to show. You also don't get the spider if the penny tries to spawn on top of you until you actually pick it up. So that's sticks, stones, interacting with hearts, and with pennies. It's a lot of things to go over. Let's head over to the code, see how it goes. So the first thing is that these sorts of pickups are, in fact, entities. So you create your pickup entities the same way you create any other entity. You find something that is more or less what you want. So in this case, I took the penny. You change the way it looks using the anim2 path. Here, we've got our own custom anim2, which we will look at in the editor today. It's a thing on the ground, so it doesn't have any HP or collision damage or anything. This one, for some reason, has 24 grid collision points. I don't really know why, but maybe because it's more round. I don't really know. This collision radius is the size of the object. We will be using the size of the object later in our calculations. But we hard-coded the variant again. And now I've got a good explanation for why we need to hard-code these variants for the entities. Because when you've got this ID number, great, you know that it's of ID 5. Before we were assuming, well, if you don't list the variant, then it'll just take the next variant. Well, then you run into trouble with subtypes. Because how would we know if sticks and stones are supposed to be the same variant but different subtypes? if we didn't include any other information. It would just think, oh, maybe they're supposed to just be two different variants. It's a big old mess of numbers, so it doesn't know which one should be assumed to be the next larger one and which one should stay the same, and then you change the next one down. So is it, if we left this out, what would the variant end up being? Because the variants for the pickups are very far removed from one another. Because the heart is 10, and then the coin is 20. If we picked a next variant, should it be 0? Should it be 1? Should it be 2? 11? 381? It's hard to know which variant ought to come next. And then if we did want something with the same new variant but different subtype, how do you tell it? There are a lot of problems with trying to get it to do that. So for now, until any other method comes along, you set the ID, you set the variant, you set the subtypes. You pick a sufficiently large random number for the variant and kind of hope it doesn't collide with anyone else's mods. So here, we've got stones, we got sticks, we've got 2 different anim2 files. The rest is all pretty straightforward. Just no damage, no health, normal friction, normal size, so on down the line. If you've seen any of my custom entity videos, this is more or less the same, and I've been talking here for a while just so that you could see all the details just in case. So now that we have the entities set up, we should probably look at the anim2 files. So we just go to File, Open, and we go back to our GFX folder, because it's Resources, GFX, and then these, because that's where it wants to find them. And we'll open up either one of them. It doesn't much matter. Now this, I took the anim2 file for the coin and reworked it a bit. These are not the only anim2 files we're working with today. So if you look at idle, it just sits there and it flashes, and then it sits and flashes and sits and flashes and sits. Up here, it bounces, collect, it goes whoosh, and then it's got a very long waiting time where it's invisible. I don't know why it has a length of 14 when only 6 frames of it are useful. It's kind of weird. So this is one of the 3 anim2 files. 4 anim2 files we're going to be working with today. So stone is really boring. Stick is just as boring. It's mostly just a sprite sheet swap. The interesting ones are for the user interface. HUD pickups.anim2. Now this is one that comes with the game and works with, let's bring up the sprite sheet so you can see it. There we are. So here's the sprite sheet. I added my stick and my stone to it. But these are all the other normal ones, and as you scroll through the animation, it goes through each of these original types of icons. And then if you look at completion normal, it goes through each of those, and completion hard, it goes through the ones with the red around it. Now you'll also notice that down here at the end, I added my stick and my stone to it, such that I can reference them the same way you would reference any of the rest. So all you do is you bring the playhead to where you want your frame, you hit Insert Frame, let's see. It inserted the frame where I had it selected. So you want to bring it to the end, clicked here, and insert the frame there. So now we've got 2 frames of the stone. And then say we wanted it to not be the stone anymore, we wanted it to be the key. You go to crop X and crop Y. Crop Y is 0 because it's at the top. And then crop X, it's about 16 over. Yeah, 16. There we are. Now, this frame is the key instead of nothing. So when you reference it in the code, all you have to do is go to the the animation layer 0, and then go to frame 10, 11, 12, 13. So when you're looking for still images, you can make an animation where each frame is a different thing that you need. Now this one was another one where I just stole from what they had, added a little bit onto it, added a little bit onto it. Now, if we open HUD numbers, this one I made from scratch. I made the animation called idle because it's just standard. But this one I made the sprite sheet from the numbers in the HUD. I couldn't find an actual image of them, so I just recreated it. So I made myself a nice little sprite sheet, has each of the numbers in it, and then for each frame, I just went through and made each frame a different number. So if you go to frame 5, it's the number 5. Frame 9 is number 9. So when we need the numbers in the game, we have them in a nice friendly format. It's not that hard to make. It's 9 pixels tall, each number is 7 pixels wide. You might want to make it 16 by 16 because that's the dimensions they tend to work at, but you only need 7 by 9 for each one. And as you can see, the first one starts at crop 0, 0, then 7, 0, and they're all 7 by 9, 14, 0, 21, 0, 28, right up here in the crop area. That tells you which part you need. Next time, we're likely to work with this triggers layer here, but for now, we're just making pictures that we're going to be rendering in the game. So those are the anim2 files that we need. It's generally how they work, and I'll show you how we make them do what we need in the code. So we come back into our main.lua, because you always need that main.lua. We register the mod as always. We had a nice little sound, so we're going to need this SFX manager, the sound effects manager. We need a global object. We don't want to write it out all the time, so we just call it sound, sort of like we call game, game. Very simple. We register the entity variant once. Even though we have 2 different pickups, they're both sticks and stones variants. So we only need that one number to work with both. That's the benefit of working with subtypes. So then we have sands here, sticks and stones. The subtype for the stone is 1, subtype for the stick is 2. Then we have a table for the constants for the layout, for where the images are located, because I don't want to type out this vector down in the middle of nowhere. You don't know where it came from. I want people to know very clearly that it's the user interface layout for the stick icon, the stone icon, the number of sticks, and the number of stones. We'll skip over the save state and the update for now. We're going to come down to the rendering. While it's fresh in your mind, thinking about anim2 files, I'm going to show you how to render something directly to the screen without an entity involved. So when the mod loads, we need to load up our HUD pickups, so the icons, and then we also load up the numbers that I made. So you make a variable, you make it into a sprite. Sprite, open, close. Then you take that thing and you load the anim2 file. It assumes resources. So it's resources gfx UI HUD pickups.anim2. This can be located wherever you want. This just helps people to know what sort of thing it is. It's graphics for the user interface. And then this true, I need to actually look up what that is forcing. So sprite, when we, let's see, when we load it, that one is a Boolean for what it calls load graphics. I have a feeling it's saying just get it going right away. Haven't really tested that myself. But I know with true it works. Haven't tried false, so I don't know if that makes it not work. We'll skip render number for a second and come down here to mod on render. So it's a post render callback. Mod, add callbacks, post render. sends it up here to on render. So this happens twice per update, so like 60 times. 60 times per second. So this is where we render the pickup HUD, the heads-up display. So we grab the player because we need to know things about the player. We set the frame for the HUD pickup. So this is the icon, idle, and then this frame number should have been a constant too. This is just really sloppy. Yeah, we should fix that up here too. So not only do we have the icons and the numbers, but we also have stick frame equals 11, stone frame equals 12. So GUI layout dot stick frame is 11. GUI layout stone frame. So we tell it to set the frame of HUD pickups to idle and then the picture of the stick. Then we tell it to render it. The 0 is the layer. It's the basic layer from any NM2 file. And then we tell it to render it at the stick icon location. Then we change what HUD pickups is set to. We change it to the stone frame, and then we render that, which is why we only need one sprite for doing all of the pickup icons. We can just take that one sprite, change what it's looking at, and render that, then change it again, render that, change it again, render that. You only need the one, you don't need to load one for each separate icon. If you're doing animations, you might want to have a dedicated sprite for the animation, but when you're just taking still images and displaying them at different parts of the screen, this works great. Then it says to render a number. Which number? The number of sticks the player has. So we have player, they have custom data that we are assigning called sticks. And where do we put it? Or what number? No, this is where. So this is the layout. This is a vector from the top, the stick number location. And then for the stones, you get the player's number of stones and you put it in the stone number location. That's what this render number does. You give it a number, you give it a position, and it'll write the number. It's always a 2-digit number. So we take, if n doesn't exist for some reason, who knows, it shouldn't ever not exist, but if it doesn't, for whatever reason, we set it to 0, because that's a perfectly good number for when it doesn't exist. Then we set the frame in the number NM2 file to be math.floor of n over 10. So when you have 7, you divide it by 10 and round it down, it becomes 0. When you've got 23, divide by 10, round it down is 2. All we're doing here is grabbing the number in the tens place. And then we render it at the current position that you were told to render it at. Then you grab n mod 10. So we have probably talked about modular arithmetic before, but mod 10 grabs the ones place. So 47 mod 10 is 7. 31 mod 10 is 1. 50 mod 10 is 0. You can do this for any number though. So if you're thinking about a clock, it's mod 12, kind of. If you think of midnight and noon as 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, back to 0. So we grab the tens place, we grab the ones place, and then we render it slightly offset. You can do this sort of vector arithmetic. You take the position you were given, add it 6 to the right, down 0. So this is what draws our current number of sticks and stones. So here we are, rendering things to the screen without any entity involved, which could be really quite fun. But we're going to have to experiment a bit to see the layering of it, because in my initial testing, it layers underneath the hearts and the active item. There might be a way of pushing it higher. We'll have to investigate that, because it gives you a lot of flexibility in the sorts of things you can do when you could just draw straight to the screen. Can make menus, can make all sorts of things. This is just a little taste of getting things directly onto the screen. So we know how to draw it, but we haven't shown how to actually get the sticks or the stones, how to pick them up, how to store them, how to prevent them from going away. We'll cover that now. So we're still going to skip save state for the moment. We're going to go to on update, because we've done this a million times. Every episode, post peffect update, on update, it sends in the player, we do some things. We've got slightly different initialization code here. We'll talk about the first one, and then we'll skip the second and come back to it. So the first one is the standard beginning of a run. You initialize how many of each they have. I put 49 and 2 just such that we had some numbers you could see. Then, after you do the regular initialization, then we're going to look at the entities in the room. That's the only thing this loop is doing. We're looking at what is in the room. So we use the same one we've used before for entities in the pairs and get room entities. We do some things. Then we check if that entity is a pickup. So it's of type pickup. And now this part is crucial. This is collision detection code. This is determining, are they touching? So you take the player's position, subtract the entity's position. That gives you a vector pointing in either direction to the player, from the player to the entity, or the entity to the player. The order here doesn't matter, because then we take the length of it. The length of vectors is always positive. We just want to know how far apart they are. So this grabs a vector, which we then take the length of. We compare that length to the player's size plus the entity's size. So let's do a little diagram. Say you've got your player here. Oh, I don't want to do it in green. So let's say your player is here, and they're 3 wide. They're, probably don't want to use those. 2 wide. They don't look great either. 2 wide. And then you've got a coin that is only 1 wide. So you would need 1, 2, 3, 4, 5 to be their distance between them before they're actually in contact. These sizes are radii. They're from the center out to their edge. So player size plus entity size in this case is 3. Once we're at 3, they're more or less touching. I use the less than here because you want it to be just slightly less than that. When you include it being equal, you can actually trigger the event without actually picking up the object. Once you get to less than, I found it to be nearly impossible to do, if not completely impossible. I'm not going to say completely impossible because who knows? Weird fringe things happen. But essentially, this is one-line collision detection of circles. If you want a square bounding box, you need different code. This is for circles. So we do circle collision between pickups and players. So if that's true, welcome to your on pickup code. This is what you've wanted for an on pickup callback, but we don't have an on pickup callback, so we wrote our own. It's what we do. We're programmers. We write our own when we don't have it. Now, I would want this to be a separate function. I would want this to send it somewhere else and do the work. But unfortunately, user data, so that's player, entity, anything you get from the game, can't be sent via Lua functions. When it gets there, it's a table. It's not usable anymore. So you have to do it here. Or send it out to a global and just, it's a nightmare. So we're just doing it here. So we've gotten to on pickup. Then we decide what to do on pickup. So this first bit is for the sticks and stones. if the variant is sticks and stones. So we're trying to pick it up, it's sticks and stones. You check that it's idle. If it's dancing around, being collected, anything else, you don't want to bother it. It's doing something, it's appearing. You can't pick it up until it's on the ground and idling away. Okay? And it's picked is nil, so it hasn't been picked up yet. Because it'll still exist for several frames after you touch it and try to pick it up. So you need to tell the system that, yes, we've touched it, we're picking it up, don't worry about it anymore. So if it's a stick or a stone, it's sitting on the ground, and we haven't picked it up yet, then we do stuff. That's when we trigger picking it up. Step 1, say you're picking it up. If you don't say you're picking it up, you're going to try to do it many, many, many times. Then, you set its collision class to none, such that you don't push it around while you're picking it up. So, entity collision class is entity collision class dot end call none. You can set this for any sort of entity. You can change it from none to all sorts of things. This is how you determine what it runs into. Okay, so we've set it to not collide with things. Now we tell it to be collected in a graphical sort of way. So we take the entity, we get its sprite, so we get how it looks, and then we tell it to play collect, and we force it to be true. No matter what else it was doing, you're going to be collected now. So entity, get sprite, play, collect, true. Then we make it sound like it's being collected. Sound, play. Then you give it the ID of the sound. Right now, I have not been able to make a custom sound effect work. So for now, just use the inbuilt sound effects. Plop is really nice for picking things up. Then it's the volume. It's a float between 0 and 1. 1 is full volume, 0 is muted. Frame delay. So you say play it now, but you could delay it a bit. If you don't want the sound to play for 6 more frames, you just put a 6 here. If you have a reason to delay it, you can delay it. Do you loop the sound? Because you can start it, you can hit play and have it loop if it's a sound that should always be going. So if you have a waterfall, but then you have to tell it to stop. And then the last one is the pitch. This one's a float again, but it can go above 1. So if we wanted higher pitch, we can go up to 2, 3, 7, or down to 0, where it gets really weird. But 0.5, drop it an octave, make it half the speed. So that's playing a sound. We set up the sound all the way at the top, the SFX manager. We tell it which sound effect. There's an enumeration listing all of them. Volume, delay, loop, pitch. All of these could be set to constants if you wanted, such that it's more memorable what each one of them does. I'm not super thrilled to do it at the moment, but I might actually decide to do that at some point. Then, depending on whether it's a stone or a stick, we determine which to give the player. Because all of these other things will happen whether it's a stick or a stone. Doesn't matter. But when you add it to the player, it matters. So if it's a stone, you give him a stone. If it's a stick, you give him a stick. Super straightforward. We've used get data before. If you wanted, you could have a declaration up here. Local player data is player get data. And then down here, player data dot stones. It's a perfectly reasonable way to do it. I just didn't do it this time, because I want to show you the different options for how to code it. And you might want to get used to having multiple extended sorts of objects like this. So we've given the player an extra stone or a stick, depending on what it is, and then we save the state. This is really super important and very easy to forget when you're doing your initial testing, is that if the player leaves the game, the player object ceases to exist. It doesn't get reloaded with all your custom data on it. So if there's anything that you want to be able to persist when they exit the game and continue it, you need to save it. Up to this point, none of our data has been important enough to save it for when they continue. It's all ephemeral things like charging up your shots. This you need to keep, such that if you leave the run and continue, you still have that number of sticks and stones. So we call save state, which comes up here to save state. Once again, we need info on the player, so we get info about the player. We probably could have put player in here and put player in here and just passed it in. It's a reasonable way of doing things. Oh wait, no you can't. Like I said before, user data can't be sent to Lua functions. If you sent player here, it would not work. It's sad, but it's true. So you have to get the player. Or have a global player, something. But you need the player. So we initialize our save data. Our save data is a string. It is text. So you need to be able to encode your information into a string and then decode it back out when you need it. If we had a JSON interpreter that worked great, we could take a Lua object, turn it into JSON, save it as a string, and then when we bring it back out, we can decode the JSON and then have a Lua object. That is the ultimate goal eventually. Whether or not we can do that at the moment is a little sketchy. You can probably do it in the debug mode, but I don't want to require that. So for now, I'm going to show you a very simple way of working with the save data, and then you can decide how you want to do it for your mod. So what I do here is I create a 4-character long save file. All it does is save how many sticks and how many stones you have in the same order every time. So it saves your sticks and then saves your stones. If the number of sticks is less than 10, then you need a 0 pad on the left. Because if you have the numbers 9 and 3, it's very clear that you have 9 sticks and 3 stones. But if you have the numbers 9, 1, and 3, do you have 91 sticks and 3 stones? Or do you have 9 sticks and 13 stones? Not clear. So you have to 0 pad it to be certain that you have 4 digits so you can uniquely tell exactly how many sticks and exactly how many stones. There are other ways of accomplishing this, mind you. You can have a comma separated file. You can have a tab separated file, a semicolon separated file, and then you can split it out by those characters when you're not certain how long your data is going to be. But since we are certain they will never have more than, let's say, 99, oh, we forgot to put that in. That's problematic, because now they can have more than 99, and it'll try to print more than 99, and it'll all go haywire. See, I like showing these sorts of things because your programs aren't going to be perfect. You'll forget something, but you can always fix it. So if you look around, here we've got math.floor, because it's important to see things in context such that you go, do they capitalize math in this or do they not? They don't. So math.min of 99, comma, that plus 1. Such that you can never have more than 99. And thus now we're absolutely assured it's only a 2-digit number. For the most part. You're still probably going to want another check somewhere else just in case you make an item that gives you a certain number of sticks that's more than just 1. Like the quarter. You'll want more checks, but for now this is going to do the job. So we make ourselves a string that is 4 characters long, because we 0 pad if it's less than 10, and then we take the save data and append our number of sticks to it. So when you have these 2 dots, it's taking 2 strings and shoving them together. So we have save data, you append a 0 onto nothing, it becomes 0, then you append 3 onto that and it becomes 0, 3. And if you have 47, it skips this and just appends 47 onto that, 0, 3, 4, 7. I have the debug string here such that I can see what data it was saving. It's not crucial anymore. And then you say mod save data and then your string. I know this isn't in the documentation anywhere, but if you look under namespaces list and then Isaac, it has these functions: save, load, has, and remove. People are tempted to use these. You don't actually have to. Because in our fancy old main.lua in the resources, in the game itself, when you register your mod, you are given back add callback, which we use all the time, save data, load data, has data, and remove data, which uses Isaac, remove mod, has mod, load mod, save mod. It's already in there for you. It's built into registering your mod. So all you do is you say mod, save data, and then your save data. It stores it in a variable, and then when you leave the game, it writes it to a file. Well, that's all well and good, but then you have to reload it, right? That's why we skipped over this part here. Now that we know how it's saved when you leave the game, we now can say how you load it when you come back. So when you start a run, the game's frame count is 1. When you start the game, the player's frame count is 1. So it's when you start a new run, but also when you continue an old run, that the player entity comes into existence and has a frame count of 1. So if the game's frame count is 1, then it's a new run. The player's frame count is also 1. But that doesn't matter. You set up the initialization. If the frame count is not 1, so you continued, or you're in the middle of a run, then you check if the player's frame count is 1. If you're in the middle of a run that you didn't exit out of, the player's frame count will not be 1. But if you just continued, the game's frame count, not 1, but the player's frame count is. And then you check whether or not the mod even has data. You might not have saved anything. So if you did in fact save something, which you should, then you get mod data. So you load your data, mod, load data. So you take that string that is in a file and throw it into this variable. And then you just translate that string back into what you want. So I take the substring of that string from position 1 to position 2, the first 2 digits. Turn them into a number, throw them into sticks. Then I take that same string, take positions 3 through 4, 3 and 4, turn it into a number, shove it into stones. It's all it takes to save and load your data. And even if they exit the game entirely and then start it back up and then continue the run, it still works. They'll still have the same number of sticks and stones as when they left. So that's the entirety of sticks and stones, because the rest of this is almost. We're almost done with sticks and stones. So that's the pickup. But we have an animation here, collect. Takes a while. You don't want to remove the entity right now because then they won't see the animation. So later on, so this is a different if. So this is outside of, is it a pickup within range? We have a new if. So it's not a pickup within range necessarily. We're checking, is it a pickup that has been picked up and is in frame 6 of its animation? Because that collection animation takes a very long time, and we only want the first 6 frames of it. So a pickup that it has been picked up is in frame 6 of its animation, then you remove it. Because that's the timing at which you want it to go away. Poof. So that's all there is for sticks and stones. We've got the pickup code, we've got the saving, we've got the loading, we've got the user interface with the icons and the numbers, and we have removing it once the time comes. This last bit of code here is all it takes to detect picking up some other type of pickup. So now, instead of looking at the collision detection, because that's taken care of for us for coins and hearts and whatnot. So we're not going to do collision detection. What we're going to do is check whether or not it's playing the collection animation. Because we know it's going to play that animation when you collect it. And we haven't seen it being picked up, because again, you only want to trigger this once, not for every frame of the collection. So is play and collect, hasn't been picked up yet, then you say it has, because you only want to do it once. And then you just have an if and series of else ifs for each type of object you want to detect. The variant is coin. Do something when you pick up a coin. Hey, let's add a blue spider at the player's position. If the variant is a heart. Hey, they picked up a heart. Let's give them a blue fly at their position. If they pick up a battery. I didn't feel like doing anything with the battery. One thing to know about detecting a battery pickup with this method, by this point, the first frame of the collection animation, they have already gained their charge. So if you're going to try to circumvent the charge, you're going to have to do it a different way. But if you want to give them a potential of getting some other bonus when charging with a little battery, this is the place to do it. And by doing it this way without the collision detection, you don't have to worry about whether or not they're able to pick up the pickup. Because if they can't pick up the heart or the battery or anything else that they can't pick up, it won't trigger this code, because it won't trigger the collection animation. It's really handy, such that you don't have to write in all those potential exceptions and maybe forget one of them. But this has been a very long episode. It's got a lot of interesting stuff in it. Hopefully it gets you on the right track for making your own pickups. Now, this doesn't make the pickups do anything. I know. But that's really up to you as the designer. Do you want this to be ammunition for your bow? Do you want this to be like the flames for Bethany in Afterbirth? Do you want this to be... You see where I'm going with this? They could do anything. But this first step is crucial, because you can't have them do anything if you don't have them, if you can't pick them up, if you can't manage them. But that's all I've got for today. I'll see you in the next episode of the Modding of Isaac with Lyte.